In this video, we're going to look at determining a break-even point for a business model. So first, let's make sure we understand the scenario. In a business, you have your business cost, and this is just the cost of doing business. So paying rent, buying the supplies for the stuff you're working on, etc. And then you have revenue, and the revenue is the money you bring in for selling a given product or whatever. And so when we talk about the break-even point, that's the point where you don't lose money or you don't gain any money by being in business. In other words, the break-even point is when the cost equals the revenue. So what we're going to do is we're going to have a scenario and we're going to find this break-even point when the cost equals the revenue using systems of equations. So we're going to set up two linear equations, one for the cost, one for the revenue, and then we will solve for the break-even point by using a systems of equations approach. Alright, so here's a scenario. A company is planning to manufacture computer disk. The fixed cost will be $60,000 and it will cost $200 to produce each disk. Those are some really expensive disks. Each disk will be sold for $450. So, what we want to do, like I said, is set up an equation for the cost. We want to set up an equation for the revenue. And then we want to determine the break-even point by solving the system of equations when the cost equation and the revenue equation are equal. So here it says to set it up as a function, which is the same as an equation, except we're going to be using function notation. And the type of equations that we've been working on writing are linear equations. And when we write linear equations, we write them in the slope-intercept form, so that's our y equals mx plus b. So basically we need to determine a slope and a y-coordinate for the y-intercept in order to write our equation. So we're going to start out by writing a cost equation. So when we read this scenario, we need to pick out the numbers that have to do with cost. So it says there is a fixed cost of $60,000 and it will cost $200 to produce each disk. So those are the numbers associated with cost. And now we need to write our cost function for this. So this is going to be a linear function, and since it's a function and they're telling us what letter to use, we're going to use c of x instead of y. And then we basically need to decide what is our m and what is our b, and that'll give us the linear function. So in the scenario, we have a fixed cost of $60,000, and then we have this variable cost of $200 for each disk produced. Well, in the equation, the thing that is driven by a variable is the slope. And so if we let x equal the number of disks produced, which is what they tell us to do, then the thing that will change with the cost being multiplied by the number of disks produced is the 200. So, in other words, if I have 200x, then every time x goes up, that's going to increase my cost. And then the thing that isn't driven by the number of disks but is held steady is your fixed cost. Your fixed costs are stuff like rent, having your snow plowed, things like that. There's too much snow in the world. Alright, so this is the linear model for the cost function. Now, just to kind of help you see the scenario better, this is writing it in the mx plus b form because that's the form that's given, but the story falls more in line with the equation being written as 60,000 plus 200x. In other words, I have $60,000 that I have to pay no matter what, and then I have this cost of $200 that goes up for each disk. So my cost of doing business is going to be 60,000 times 200, 60,000 plus 200 times the number of discs that I sold. That goes along more with the story. And if it helps you to write it in that order, you're very welcome to. Either way they're completely the same and both acceptable. So those are our cost function. I'm going to go ahead and get rid of the second one just to clean things up a little bit, and then we'll work on the revenue function. Okay, in our scenario, the revenue function is about the money you get when you sell stuff. So the information we have for revenue is just that each disc will be sold for $450. So again, we're going to use function notation, and they tell us to use the letter R. So it's going to be R of X equal to, and then our revenue is solely based on number of discs sold. So for each disc I get $450. So for the total revenue, it would be 450 times the number of discs that I sold. And that's it for the revenue function. There's no guaranteed cost not associated with the disc, so there's no y-intercept, so to speak. So that's our revenue function. Now, as I talked about in the introduction, if we're looking for the break-even point, we're basically looking for where cost and revenue are equal. And so what that means is setting these two equations equal. Now, if you think about it, and this is where it is a system of equations, but it's a little different than how we've done systems of equations. So if I set my cost function equal to my revenue function, that's what we're doing. But you don't need to show this step. Essentially, where we need to go is we're going to set the right side of my function for cost equal to the right side of my function for revenue. And that gives me the 200x plus 60,000 equal to the 450x. Once I get those set equal, it's just a matter of solving that linear equation in one variable. So to solve this, I would actually start out by subtracting 200x from both sides. When I do that, that gives me that 60,000 equals 250x, and I'm going to bring this up here to give me a little bit more space to work with it. The only thing left to do to solve this equation, we're just getting x by itself, is to divide the 250 on both sides. And that gives me 240 equals x, or x equals 240. And so what that means is for this company to break even, they need to produce and sell 240 discs. All right, there you have it. I hope you find this helpful. Let me know if there are any other questions I can help you with.